Out there in the colossal haziness of space, the James Webb Space Telescope has been investigating the smallest details for answers about the universe. NASA's new eye above has been capturing surprising pictures of stars, enormous planets, and exoplanets. At last, something frightening has been found, something so monstrous it could shake the very foundations of all that we understand. Scientists are scratching their heads, questioning whether it could ignite the deepest questions about existence and compel us to reevaluate everything. As we examine the latest discoveries of the James Webb Space Telescope, they could profoundly challenge our perception of the universe. When we explore the edge of the universe, we are referring to the observable universe. The observable universe seems like a window through which we can examine the vastness beyond. It encompasses everything we can currently see, measure, and investigate using telescopes and space probes, a collection of stars, galaxies, and celestial bodies within our field of observation. However, the observable universe is only a small slice of the entire universe. Imagine it as a single slice of a massive pie that we are able to review and comprehend. While the total size and shape of the greater universe remain a mystery, scientists estimate the width of our observable bubble to be around 93 billion light-years. A light-year measures the distance that light, the fastest thing in the universe, travels in 1 year. Approximately 5.88 trillion miles, 9.46 trillion kilometers. So, when we discuss the observable universe being 93 billion light-years wide, we're talking about an immense expanse. Around 13.8 billion years ago, the universe burst into existence in an unfathomably powerful event known as the Big Bang. Since that moment, the universe has not only been expanding but accelerating in its growth due to perplexing forces like dark energy, which appears to drive this expansion further outward. As the universe expanded, matter began to clump together under the influence of gravity. This gravitational force united particles, birthing spectacular structures, stars, massive galaxies, and eventually planets like Earth. Picture the universe evolving as these immense structures formed, creating the dynamic yet ever-developing phenomena we observe today. Despite its colossal size, the universe is astonishingly empty. If we were to scale down our entire solar system to the size of a quarter, the nearest star would still be about 2 soccer fields away. This vast emptiness extends even within our Milky Way galaxy, which is just one among billions in the observable universe, giving us a sense of the overwhelming magnitude of space. You might ask, why can't we see everything that exists in the universe? There are several reasons for this limitation, the most significant being the speed of light. Even though light is the fastest thing in existence, it still takes time to travel through space. This means that when we observe distant objects, we are essentially looking back in time. The farther an object is, the longer its light has taken to reach us. It's like peering into a vast time machine, unraveling the history of our universe as we observe galaxies millions or even billions of light-years away. The universe itself is expanding. Imagine spots on the surface of an inflating balloon. As the balloon stretches, the spots move farther apart. This principle applies to the universe, where galaxies, like those spots, drift apart as space itself expands. This expansion causes the light from distant objects to undergo a shift known as redshift, where light stretches to longer wavelengths, often appearing reddish. Considering these factors, light's travel time, the dynamics of space, and the universe's ongoing expansion, it's unsurprising that we haven't fully seen all the universe has to offer. Even with our highly advanced telescopes and technology, our view remains limited by these fundamental properties of the cosmos. The journey to understand the potential edge or boundaries of the universe has captivated the minds of countless individuals across disciplines. While definitive answers remain elusive, 3 main theories have emerged, each offering intriguing perspectives on the vastness of space. 1. Infinite expansion. The first theory suggests that the universe expands endlessly, continuing infinitely without a discernible edge. This idea aligns with the cosmological principle, which states that the universe appears uniform and isotropic from any vantage point. If this principle holds, it implies that the universe lacks boundaries and grows infinitely in all directions. 2. Finite but boundless. The second theory proposes that while the universe may indeed be finite, It lacks a clear edge. Instead, it might resemble a massive sphere or curved space like Earth. In this scenario, if one were to travel indefinitely in any direction, they would eventually return to their starting point, much like circumnavigating the globe. 3. The multiverse hypothesis. The third theory introduces the concept of a multiverse, suggesting that our universe is just one among countless others. Imagine an infinite number of parallel universes, each with its own set of physical laws, constants, and properties. These universes might operate completely independently or could be interconnected in ways we have yet to comprehend. Through complex frameworks shaping a tremendous and multifaceted multiverse, the James Webb Space Telescope, JWST, remains a symbol of potential, enlightening the mysteries that lie at the enormous starting points of the universe. This unbelievable instrument has an unmatched capacity to unravel the confounding past of our universe, allowing us to peer far beyond what was previously conceivable. The JWST is a technological marvel, designed precisely to observe the universe with exceptional precision. Its advanced capabilities stretch our vision to the earliest moments of the universe. In fact, a vital report published in the prestigious journal Nature revealed the JWST's discovery of 6 massive galaxies dating back between 500 million and 700 million years after the Big Bang. Undoubtedly, these ancient galaxies are far larger than expected for their early existence, challenging prevailing theories of galaxy formation. Furthermore, their development in the early universe is genuinely exceptional. What's extraordinary about these revelations is the level of complexity in these ancient systems. This contradicts the assumption that galaxies form gradually over time. These gigantic galaxies exhibit a degree of complexity comparable to our 13-billion-year-old Milky Way galaxy. The sheer number of stars within these titanic behemoths surpasses expectations, with each galaxy boasting a total mass several times greater than our Sun. Strikingly, one of these galaxies might even have a mass up to many times that of our Sun, dwarfing the already immense size of the Milky Way. The JWST's unparalleled ability to explore the universe's hidden realms relies on its use of infrared light, an invisible spectrum to the human eye. This astounding power enables the telescope to capture the faint emissions from ancient stars and galaxies, unveiling massive remnants that have endured for billions of years. Essentially, the JWST acts as a time machine, transporting our vision back through the ages and offering a captivating glimpse into the universe as it appeared approximately 13.5 billion years ago. The continuous discovery of massive galaxies, nicknamed universe breakers, has altered our understanding, akin to rewriting history. This surprising turn challenges many of the models we had established for early galaxies. Initially, we believed galaxies formed from humble beginnings, starting as small clusters of stars and dust. They were thought to evolve gradually over time, increasing in size and complexity. However, the universe breakers have shattered these ideas. When JWST data and its high-resolution images revealed these massive structures, these colossal behemoths seemed to appear out of nowhere, defying our previous understanding of cosmic evolution. Delving deeper, scientists utilized spectroscopic techniques to examine light across varied wavelengths. This analysis holds the key to unlocking crucial insights about these mysterious galaxies, such as their structure, size, and distance from Earth. It is like an immense investigative story, with light serving as the clue to uncovering the secrets of these giant entities. The astounding discoveries from the James Webb Space Telescope have transformed our understanding of the universe to unprecedented levels. This cutting-edge telescope, operated by an international team of space scientists, has recently unveiled a remarkable finding: the identification of the oldest and most distant galaxies ever observed. These galaxies transport us back to a time when the universe was only a fraction of its current age, existing just a short time after the Big Bang. The James Webb Space Telescope, situated in the vast darkness of space, has been seeking answers about the universe. It is NASA's latest powerful instrument, capturing breathtaking images of stars, galaxies, and planets. Recently, it made a discovery so profound that it could redefine how we understand the very fabric of the universe, leaving experts both astonished and curious about its true implications. When we study the universe, we begin with the observable universe, a window into the infinity beyond. This observable universe includes everything we can currently identify with our telescopes and space probes, including stars, galaxies, and other celestial bodies. However, it represents only a tiny fraction of the entire universe. Experts estimate the diameter of our observable universe to be about 93 billion light-years. A light-year measures the distance light travels in 1 year, about 5.88 trillion miles, making the scale nearly incomprehensible. Around 13.8 billion years ago, the universe began with a Big Bang, a colossal explosion that triggered its great expansion. Since then, the universe has been growing and accelerating, driven by mysterious forces like dark energy. Matter began to coalesce under gravity, forming stars, galaxies, and eventually planets like Earth. This continuous process shapes the universe's vast size, allowing us to observe only a small portion of its infinite complexity. Even with the expansion, much of the universe remains dark and empty. Despite how far we've come in exploring space, the majority of the universe remains hidden. Even with the power of the James Webb Space Telescope, vast portions of the universe remain distant. Yet its discoveries continue to reshape our understanding, offering glimpses into the unimaginable wonders that lie just beyond our sight. The vastness of space continues to amaze and inspire. However, with each groundbreaking observation, we are slowly piecing together an increasingly complex understanding of the universe's history and future. The James Webb Space Telescope is a tool that could forever change the way we think about space, time, and the very nature of our reality. The implications of the JWST's discoveries extend beyond novel observations. They challenge the very foundations of modern cosmology. If these massive galaxies existed so early in the universe's history, it compels us to reevaluate current models of galaxy formation. For decades, scientists adhered to the idea that galaxies develop gradually, starting as small, dense clusters of gas and dust, evolving over billions of years. The discovery of these gigantic galaxies, formed within the first few 100 million years after the Big Bang, presents a mystery that doesn't align with this slow development. This finding raises new questions about the nature of galaxy formation itself. How did such massive, complex galaxies form so quickly after the universe's origin? What forces were at play during those early epochs that enabled rapid star formation and large-scale galaxy development? These questions not only challenge our current understanding of the early universe but also push the boundaries of our knowledge of physics, particularly regarding the behavior of dark matter and dark energy during the universe's infancy.